Alright, this is video 2 of my dilation series, and if you made it through video 1, you're still watching this, it means I'm probably your teacher and you have to. So, it's because my first video was pretty awful as far as the sound quality, so I think I may have been able to rectify that, and I apologize for the crumminess of the sound on that last video. Anyway, I'm going to do one more video on this, and you might be thinking, well, there wasn't really a whole lot to be said about it, so why am I have to watch another video? And the reason is because I didn't hit all the topics. So we're going to once again do a dilation, and this time I'm doing A, B, C, D. I have a rectangle, and I'm going to have my center of enlargement is at 1, 2. And I'm not going to write down what my coordinates are, and that's fine. You know what? I'm going to start. So if I had a scale factor of 2 again, scale factor of 2. Once again, this shape should be getting larger. So once again, I'm going to go 1, 2, and up 1. So instead of going over 2 and up 1, I'm going to go over 4 and up 2. 1, 2, 3, 4, 1, 2. This is B prime. In order to get to A, I'm going to go back 1, 2, 3, 4, and up 1. So back 8 and up 2. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2. And that's going to be A prime down 1, 2, 1, 2, 3, 4. 1, 2, 1, 2, 3, 4. And if you're wondering what I just did, for D, if I went, I'm going to use B as an example because it's easier. If I go over 2 and up 1, and my scale factor is 2, I can go over 2 and up 1 again, because that's the same as going over 4 and up 2. So I'm going to use that rationale with C. If I go over 2 and down 2, that'd be the same, and I have a scale factor of 2, I can do that twice. Over 2, down 2, over 2, down 2. And sure enough, that gives me my C prime. And if I want to use my ruler, oops, I just got rid of it, I could very quickly just do this. And I know what you're thinking. We just saw that in video 1. But there is something else I wanted to show you, which I think is pretty important. And I've already recognized that with my drawing, there might be a little bit of an issue, but that's fine. Because it just shows you that you can do it even if things aren't ideal. Let's say I had another scale factor. I'm still going to use my same center of enlargement. But this time, I'm going to use a scale factor of 1/2. Well, to get to A, I had to go backwards 4 and up 1. So if I go backwards 2 and up 1/2, that's my new A. To get to D, I had to go backwards 4 and down 2. So that'd be the same as going backwards 2 and down 1. And that's how I'd get to D, double prime. Here I go over 2 and up 1, so that'd be the same as going over 1 and up 1/2. And then here I went over 2 and down 2, well, that would be the same as going over 1 and down 1. And once again, the reason why I think this is significant is because it shows that, although they call it a center of enlargement, a center of dilation is probably a more accurate term, because to dilate means you can get larger or smaller, whereas enlargement, you're kind of assuming that it has to get larger every time. And what I want to illustrate is that A, B, C, D was my original shape, or my image, and A prime, B prime, A prime, B prime, C prime, D prime was an enlargement. It really was an enlargement. But then A double prime, B double prime, C double prime, and D double prime is in fact, it shrinks. And once again, if I connect from my center of enlargement, or my center of dilation, all the way out, you can see that all the points are connected, which is pretty neat. And last one. You don't need to show, by the way, you don't need to show these lines that I just drew, these purple lines. I'm only showing them because I think it's kind of neat, and it illustrates what we've just done quite nicely. But they're not necessary. All right, that's it.